about equations of lines and how to model with them. Let's say I have a slope of -7/9 and a y-intercept of 16. Let's find an equation of the line. We talked about in our last lesson y equals mx plus b, where m is slope and b is the y-intercept. Well, we are given the slope and we are given the y-intercept, so we can fill in the blanks for slope of -7/9 and 16 for b, so that our equation of our line is y equals -7/9 x plus 16. However, it's not always going to be that easy. What if I'm given a slope of -2/3 and I have a point -3/6? And we know that -3/6 is not the y-intercept because it doesn't land on the y-axis. What we still need to do is have the slope, but use our point and fill in our point, our x value for -3 and our 6 for our y value, and then solve for b because we don't quite know what our y-intercept is. This will give us then 6 is equal to -2/3 times our x value of -3 plus b. We're now able to solve for b. We'll simplify by multiplying -2/3 times -3, which is +2, and then subtract 2 from both sides so that b is 4. For a final equation using our slope and our newly found y-intercept of y equals -2/3 x plus 4. Another equation that we can use is what we call point-slope equation. We need to know a point, any random point, and we need to know the slope. Let's find an equation of the line that contains the points 2, 3, and 1, -4. We need to identify what our slope is and choose one of the points to use. So finding our slope, we take -4 minus 3 and 1 minus 2 for a reduced slope of 7. And I'm just going to choose the first point here to fill in our point slope in our equation. Our equation says that we need to take y minus the y value of our point equal our slope times x minus our x value of the point with which we chose. This gives us y minus 3 equals our slope of 7 times x minus our x value of 2. Let's go ahead and simplify by distributing our 7, giving us y minus 3 equals 7x minus 14. Add 3 to both sides so that y is by itself. Y is equal to 7x minus 11, or our function f of x is 7x minus 11. How does this then compare to slope-intercept form? Slope-intercept form is y equals mx plus b. We already found our slope and we need to use a point. This time, instead of using our random point of 2, 3, let's use our point 1, -4. So we chose our point for our x and our y, and we now need to find our y-intercept because we don't have our y-intercept yet. This would then give us y equals 7x plus b. Now let's go ahead and substitute in our x and our y values so that we can find our y-intercept. -4 equals 7 times 1 plus b. Subtract 7 from both sides gives us -11 equal to b. We now can write our equation using slope-intercept. Y equals mx plus b. In this case, y equals 7x minus 11. Let's talk about parallel lines. Parallel lines are non-vertical lines if and only if they have the same slopes but yet different y-intercepts. So notice our example. They have the exact same slope of 2 but different y-intercepts. Whereas perpendicular lines are perpendicular if and only if the product or the multiplication of their slopes is -1. We can also look at their slopes and notice that they're opposite reciprocals. So they're 3/2 and 2/3 reciprocals, and one is positive and one is negative. Let's determine whether each of the following pairs of lines is parallel, perpendicular, or neither. We have y plus 2 is 5x, and 5y plus x is -15. Let's first solve both of these equations for y so that we can pull the number in front of x as our slope. On our first equation, I need to subtract 2 from both sides so that y is equal to 5x minus 2. I know then that my slope of this equation is 5. On the equation on the right, I'll first need to subtract x from both sides and then divide everything by 5. That will leave me with y equals negative 1/5 x minus 3. Grabbing the slope, I see that my slope is negative 1/5. When I multiply my slopes together, 5 times negative 1/5, I do in fact get negative 1. I also see that by visually looking at them that they are opposite and reciprocals. Therefore, these two are perpendicular to each other. Let's find and determine if the lines are parallel, perpendicular, or neither for 2y plus 4x equals 8 and 5 plus 2x equals negative y. On the left, again, we're still going to solve for y, so I need to subtract both by 4x. That would then give us 2y equal to negative 4x plus 8, and when I divide everything by 2, I get y equals negative 2x plus 4. Pulling out my slope, we see that it's negative 2. On the right-hand side, I'm going to flip-flop my equation. So I'm just going to put the right-hand side on the left and the left to the right. So I have negative y equals 2x plus 5. I'll go ahead and divide everything by negative 1, leaving me with then y is equal to negative 2x minus 5. Pulling out our slope, I see that my slope is negative 2. Therefore, since the slopes are the same, these lines are parallel to one another. I also have in part C the equation 2x plus 1 is y, and y plus 3x equals 4. Again, we'll solve for y. I'll subtract 2, on the C, I'm going to flip-flop them around, and I see that they're already solved for y and that my slope is 2. On the right-hand side here, though, I'll need to subtract 3x from both sides, so I have y equals negative 3x plus 4. Here my slope is negative 3. If I were to multiply these together, I would get negative 6. They are certainly not opposite reciprocals of one another, and since they also are not the same slope, these are neither parallel nor perpendicular. Let's write the equation of lines that are parallel to, perpendicular to the graph of the line 4y minus x is 20, but yet contains the point 2, negative 3. Just like previous pieces, in order to do this, we're going to need to first determine what is our slope. So to determine the slope, again, we're going to solve for y. I need to first add x to both sides and then divide everything by 4 so that my slope I see now is 1/4. Now, when we're finding a line parallel to, we know that our slope has to stay the same, but I'm going to use the point 2, negative 3. A line perpendicular is opposite reciprocal of the given slope, but yet we're still going to use the same point 2, negative 3. I'm going to use point-slope form to do this. I've been given a point and a slope. So I'm going to have y minus negative 3 equal to my slope times x minus 2, which is our x value. I can simplify double negative by turning to a positive and multiply and distribute my 1/4 to my x minus 2, providing me with 1/4 x minus half. My ending result then is y is equal to 1/4 x minus 3.5. Now, when I look at my line perpendicular, we already decided that it was going to be the opposite reciprocal, so we can simplify that down to negative 4. But we're also using the point 2, negative 3 with the point slope form. Y minus y sub 1, so y minus negative 3. This time, our slope is going to be negative 4 times x minus 2. We'll distribute our negative 4 through, giving us y plus 3 equal to negative 4x plus 8, and then subtract 3 from both sides. So y is equal to negative 4x plus 5. The cost of a 30-second Super Bowl commercial has increased 1 and 6/10 million from 2010 to 2015. Let's model the data in the table with a linear function, and then we're going to estimate the cost of what it might be for 2018. Notice that each year is associated with an X value. Instead of using such large X values such as 2010, 2011, 2012, notice that we're starting off the year 2010 as year 0, and we're working our way up. Let's just choose 2 random data points. Now, because our slope is not a perfect slope and not even, this is going to be an estimate. So if you were to choose 2 different data points, your result would also be just slightly different than what we have here. Let's use the data points for 2011 and the data points for 2014. Those data points then would be 1, 3.1, and 4, 4.0. We know that in order to write an equation, we need a slope and a point. So let's first start off by finding the slope. 4 minus 3 1/10 over 4 minus 1 gives us 9/10 divided by 3, or 3/10. Now we can find the equation of the line by choosing one of those points. Let's choose the first point, just because they're slightly smaller numbers. Y minus 3 1/10 is equal to our slope of 3/10 times x minus our x value of 1. Let's distribute our 3/10 to get rid of the parentheses. Y minus 3.1 equals 0.3x minus 0.3. Add 3 1/10 to each side gives us y is equal to 3/10 x plus 2.8. We can now estimate the cost of the 30-second Supermole commercial in 2018 because now we have an estimated linear equation that fits the model of this data. But we have to figure out what is the x value, because notice that we're using the x value, we use these values here in order to create our equation. So we need to know what x value we need to use for 2018. So to do that, we'll take 2018 minus 2010, since 2010 is where we started with our data, and we get 8. We now are able to substitute 8 in where we see x, multiply and add together, and we get about 5.2. So a good estimate for the cost of a 30-second commercial during the Super Bowl will be about $5.2 million in 2018. This can be a tedious process, so what we're going to do is talk about a regression line and how we can use Desmos to find that regression line for us. So here we have the exact same data, and I'm going to pull up Desmos here, and I'm going to show you how we can do this. On the left, we have our table, and on the right, we have a portion of the Desmos screen. We would like to add, and we're going to add our own table. On the left, I'm going to put our x values as 0, 1, 2, 3, 4, and 5. And on the right, I'm going to put our y values of 2.9, 3.1, 3.5, 3.8, 4.0, and 4.5. If I move my screen over, you can see those points here are listed, and they are in a linear type model. In my second piece here, I'm going to click into another line, and I'm going to start typing in, using my ABC, I'm going to type in y, and I'm going to use the A sub B button, sub 1. I'm also going to use the little, put my arrow over and use the little tilde button, and put MX sub 1, put my arrow to the right, plus B. Well, what I'm doing is telling Desmos to use the y values in my category up above and use my x values in the category up above. Notice it's x sub 1, x sub 1, y sub 1, y sub 1. So it knows which data to pull it from. And it's given us a few items here. The items that it gives us is r squared and r. R is for a linear equation, and r squared is for a quadratic equation. Notice that our r value is much closer to 1, so it would fit the data much more closely. In upcoming lessons, we're going to talk about how we can fit a regression line to cubic functions, to quadratics, and further. But it does give us our slope, and it gives us our y-intercept. Coming back to our data here in our screen, we typed in the equation y sub 1 is about mx sub 1 plus b. We received the information for r squared, r, m, and b. So now we can use this information to write our equation. Y is equal to m, 0.314286x, plus b, 2.84762. So a much more accurate representation of our data, a more concrete, if you will. And for a more exact answer, we can find what it would be in 2018 by going back to Desmos, and we realized in Desmos that it was when x was equal to 8. So in my third line, I'm going to type x equals 8. Notice a graph popped up here, the red line, and I can click the gray circle where they overlap. That tells me that my point and my coordinate was 85.362. This tells us then that after 8 years, or in 2018, we get about 5.36 million when we predict that there should be a 30-second commercial will be in 2018. And that concludes our lesson today.